Hi, I'm Andrew, and this is Blaster Breakdown. This week I received a special delivery in the post, a package of Merlin flywheel motors. These are a brand new high torque, high RPM flywheel motor made by Flywheel The World. While mostly designed for micro-flywheel blasters, I'm going to try these out in a few different things I've got going. I'll see how they go as the final stage of a 3-stage Dominator, and I'll also check them out as a dual stage hurricane flywheel setup in this swordfish. Let's have a look inside. Okay, so here's what the inside of the swordfish looks like now. My previous breakdown video for this one is available here if you're interested in seeing what it looked like beforehand. The main change, of course, is the flywheel cage. This dual hurricane cage has been designed by Atch Attachments and is available on his Thingiverse page, which I've put in the description below. My mate Bruce printed this one for me, so thanks Bruce. Here's how the Merlin motors come. As you can see, really nice packaging. One side of the motors has the Flywheel The World logo and name, while the other says Merlin and has the longsword logo. The reason I'm trying this cage out is that I previously had a full-size cage and wheels, but found that the ACC3 short darts that we use at Bang Superstock events did not feed reliably. This is due to the slightly shorter length of the dart, plus the narrow tip not quite engaging with the standard size flywheels. Worker Gen 3s worked great as they're slightly longer with a flatter head. But hurricane wheels sitting closer together will grasp the dart sooner, so that will eliminate feeding problems, and the higher RPM of Merlins will compensate for the smaller wheel diameter. To fit the cage, you need to remove the front pair of screw posts, plus the plastic rib in between them, and a little more around. I had previously cut a hole for some Neo Hellcats, which you can see here, but this isn't necessary for Merlins, but that's okay. This may help keep them cool, which can't hurt. Otherwise, I just took my time cutting away whatever was necessary to fit the cage around the leading edge. Here you can see a 12-volt LED strip that I've added for style points. This winds around the top of the cage and between the motors before folding up a little in the space above the magwell on this side of the shell. The other end goes around the top and into the battery tray. On the other side is a little rocker switch that turns these on along with a voltmeter, and this seems pretty happy on the 8 volts or so from this 2S LiPo. From a prior build using this cage in a Strife with Honey Badger motors, I had an inkling that my velocity might be around 180 FPS, well above my target of 150 FPS. So I've cut this 7cm length of aluminium with a 14mm internal diameter, which in theory should reduce FPS and improve accuracy, but might need a little trial and error to get it just right. And that's ready to close up now. And here is the Dominator. I thought I'd start off by showing you how I've wired up this high current Mosfet. There's an excellent description of how and why these work on Reddit, which I've linked to in the description below. The benefit of using one of these is that you can keep the original switch. In this case, the Dominator comes with a 15 amp Omron clone, but even the original Nerf ones can be kept if you're using a Mosfet. A Mosfet is a transistor and uses a semiconducting material that is usually an insulator that prevents an electrical connection from being made, but can switch to being a conductor when a voltage is applied. The switch connected to the left-hand prong and the positive terminal of the battery does just this. When this switch is pressed, a connection is made between the other two prongs, which were previously disconnected, allowing current to flow. The center prong is attached to the negative wire coming from the motors, and the right-hand prong goes to the negative battery terminal. There are two additional components required. Firstly, a resistor between the left and right prongs, and this ensures that only the rev switch can trigger the Mosfet, and not any random electrical interference that may be present. and secondly this diode between the positive and negative wires going to the motors. This provides protection for the Mosfet when the motors are spinning down and can generate a current going in the opposite direction. The three prongs can be bent back and forth while you're wiring everything together if you find that easier to work with, and of course it's always good to use heat shrink to keep each insulated. I've got this 10mm heat shrink which I also like to use over the top of everything just for some added protection. At the back here I've got an XT60 connector that can pass through the stock attachment to where I can strap a big LiPo in the back. So this is actually an ongoing project where I'm comparing different combinations of motors in the same 42.5mm cage with 34.5mm wheels. I've got various setups with Neo Rhinos, Honey Badgers and now Merlin motors with XT60 connectors to allow me to swap these around without having to solder connections each time. My aim isn't necessarily to get the highest FPS possible, but to try and find a combination at a reasonable price point that gives high performance but isn't overly wearing on darts. For this little experiment, I've got Neo Rhinos first, which spin at around 37,000 RPM, then Honey Badgers at around 53,000 RPM, and then the Merlins at 74,000 RPM. Let's see what kind of results we get with this combination. Okay, Swordfish first. I've got a 3S LiPo plugged in using a standard 17mm internal diameter barrel. ACC 3s to start with, followed by Worker Gen 3s. As you can see, some high numbers, but also several decapitations. And there's an average just under 180 FPS. The Worker darts held up better, but had a slightly lower average velocity of about 172 FPS. Now I've swapped over to a 2S LiPo and installed the narrow 14mm barrel. Let's see how this goes. There's an average right on 150 FPS with ACC 3s. And about 145 FPS with the Workers. Let's have a look at the Dominator now, using new Worker Red full lengths. Some inconsistent results there, plenty of shots around 200 FPS or higher, but also some down at 140 FPS, more than you could consider outliers. And now some shots down the backyard. I'm firing at a target 50 feet away. ACC 3s first. A dart got out of alignment in the mag there. And next some Gen 3s. So much tighter grouping with the worker darts. And next we'll look at the Dominator using worker red full lengths. Horizontal spread is pretty good, but vertical spread suggests I'm still seeing variation in FPS. So there you go, some pretty interesting results I think. I'm really keen to see what others do with these flywheels. I know they're out in the community now, so looking forward to seeing some really interesting builds. Some final thoughts from me on these two builds. For the Swordfish, the flywheels are super critical at both 3S and 2S voltage. That means they're not really going to provide more FPS than honey badgers or fang revamps on 3S. However, when compared to honey badgers, they have more torque and so a quicker spin up time, so there's an advantage there. And compared to fang revamps, the stall current of 4 Merlins on 2S is a lot less than fang revamps on 3S, thus avoiding the need for a larger or higher discharge LiPo. Adding the longer, narrow metal barrel seems to help with accuracy, and by bringing the FPS down to super stock levels, I'll definitely try this one out at the next Bang event. For the Dominator, this was an interesting experiment for an ongoing project. The arrangement of Neo Rhinos, Honey Badgers, and then Merlins gave some good numbers, but as we saw, it was a little inconsistent. I was most pleased with the amount of dart wear, with few if any decapitations, and no darts getting torn up during my testing. However, the accuracy wasn't great, so I'm going to have to continue experimenting here. Let me know in the comments below if you're going to give these a go in any of your blasters. Thanks for watching, I'll see you next time.